So, okay everyone, welcome back. So, thank you so much for listening patiently and coming till here. We have understood regarding the first elastic constant, that is Young's modulus. We understood regarding the second elastic constant, that is shear modulus. And also we have understood regarding third one, that is bulk modulus. The fourth one, and very important one, that is Poisson's ratio, basically. Okay. Let me put the heading here, Poisson's ratio. It is denoted by mu or nu. Okay. So, దీని spelling mu anamata, దీని spelling nu. So, whichever variable they are using, that's completely fine. So, Poisson's ratio is like this. So, if you want to take formula, simply it is equal to given by minus of lateral strain by longitudinal strain. Lateral strain by longitudinal strain. This is the formula anamata. So, first of all, copy this. This will be enough for you to crack any diploma examination, but I will give you explanation behind it. So, I believe you guys have copied this. So, listen carefully here. See everyone, you take a member, okay. So, generally longitudinal direction is this, okay na? ఎందుకంటే highest length ఎట్ సైడ్ ఉంటే అది longitudinal direction అంటాం. Longitudinal direction. Clear? And దాని perpendicular direction మనం ఏదైతే తీసుకుంటామో that is lateral direction. That is lateral direction. Okay na? Clear? Now see, when I am applying a force or causing stress along lateral direction, see, I am applying a force along longitudinal direction here. Force or stress, force longitudinal direction apply chesthe automatically stress is coming up anamata. Due to this, what actually happens is this particular member will undergo elongation like this. This particular member will undergo elongation like this. Okay na? Now if you see here, there is load applied. There is load applied along longitudinal direction. Load is applied along longitudinal direction. So stress is produced along longitudinal direction. Okay na? Stress ee direction lo undi kabatti there is strain already which is there along longitudinal direction. Ikkada daaka antha arthamaindi anukuntunna. Okay na? Kani due to this load along this direction, there is also some strain along this particular direction. You can see here. Let me show it. So due to this one, you can see there is some strain, or basically there is some compression anamata. Clear? Okay. So you are applying load along one direction, kani strain is being produced in the perpendicular direction as well. ఈ డైరెక్షన్ లో స్ట్రెయిన్ అనేది ఉంది ఆల్రెడీ ఈ యొక్క లాంగిట్యూడినల్ డైరెక్షన్ లో, కానీ దాని పర్పెండిక్యులర్ డైరెక్షన్ లో కూడా స్ట్రెయిన్ ప్రొడ్యూస్ అవుతుంది. ఈ డైరెక్షన్ లో ఏ లోడ్ లేదు, కానీ పర్పెండిక్యులర్ గా యాక్ట్ అవుతున్న లోడ్ వల్ల ఇది ప్రొడ్యూస్ అవుతుంది అనమాట. సో దిస్ ఎఫెక్ట్ వి కాల్ ఇట్ యాజ్ Poisson's effect. Okay, let me put the definition here. Poisson's effect. When load is applied in longitudinal direction, when load is applied in longitudinal direction, when load is applied in longitudinal direction, okay na? When load is applied in longitudinal direction, strain is produced. Strain is produced along lateral direction okay. Strain is also produced along lateral direction anamata. Okay na? Clear? So strain anedi lateral direction lo kuda vastundi. So this particular thing, strain is being produced in lateral direction. So this effect is called as Poisson's effect. So this effect is called Poisson's effect. This effect is called Poisson's effect anamata. Understood? This effect is called as Poisson's effect. Okay, so you are applying load in one particular direction, but the strain is being produced in perpendicular direction also. That effect is called as Poisson's effect. I believe it is completely clear here. Okay, so the ratio which decides, okay, so Poisson's ratio gives us the idea regarding lateral strain. Kada? So Poisson's ratio is ratio of, okay, Poisson's ratio is ratio of epsilon lateral to epsilon longitudinal. So Poisson's ratio is equal to minus epsilon lateral whole by epsilon longitudinal. And why do we put this negative sign? మీకు అందరికి తెలిసే అనుకుంటా, మీరు ఓన్గా కూడా రాయొచ్చు. When this longitudinal strain is actually tensile in nature, positive, you would see that this lateral strain is actually compressive anamata. So to nullify that negative sign, ఇది always negative ఉంటుంది అనమాట. ఇది పాజిటివ్ అయితే ఇది నెగిటివ్, ఇది నెగిటివ్ అయితే ఇది పాజిటివ్ అనమాట. సో బేసికలీ దిస్ రేషియో is always negative అనమాట. To nullify that negative sign, we are taking another negative sign here. Okay, let me write down the negative point, another point here. Okay, so generally epsilon lateral is less than 0 when epsilon longitudinal is greater than 0, or epsilon lateral is greater than 0 when epsilon longitudinal is less than 0. Understand? Okay, so this implies epsilon lateral by epsilon longitudinal is mostly less than 0. Okay na, that is negative anamata. Okay na, so to nullify this negative sign, to remove the negative sign of the ratio, minus is kept anamata. Okay, so hence the formula for Poisson's ratio always has negative lateral strain by longitudinal strain. Clear? Understand? And keep in mind here, note point is, this is the ratio, load is being applied along longitudinal direction. Load is applied in longitudinal direction. Load is applied in longitudinal direction. So you are applying load in longitudinal direction, so there is strain produced in lateral direction. Okay, na clear? If you apply load in lateral direction, strain will be produced in longitudinal direction. So all are Poisson's effects only. So simple thing is, when you apply load or create stress in one particular direction, there is strain produced also in perpendicular direction. That perpendicular direction strain production effect is called as Poisson's effect anamata. So I hope it is completely clear to everybody. So this Poisson's effect value is also been decided. So you can copy this. అంటే ఇలా ఎక్స్పెరిమెంట్ చేసి కనుక్కొని మనం పక్కన పెడతాం అనమాట. సో విల్ యూజ్ ఇట్ అనమాట బేసిక్గా. సో ఐ హోప్ ఇట్ ఈస్ కాపీడ్. యూ కెన్ కాపీ దిస్ యాజ్ వెల్. ఓకే, యూ కెన్ కాపీ దిస్ యాజ్ వెల్. క్లియర్? అండ్ యూ కాపీ దిస్. డన్. యూ కెన్ కాపీ దిస్. ఓకే, దట్స్ ఆల్. Clear? So this is the thing. I believe it is completely fine. Hope there is no confusion at all. Clear everybody? Okay. Now the next thing is basically we need to know the relationships between these elastic constants. Ante basically the formulas between these elastic constants anamata. Okay. Adi direct ga formula telusukunte saripotundi. Even in your syllabus it is written derivation not required. So let me put the heading here. Relationships between elastic constants. So these elastic constants are E, G, K and mu anamata. Okay na? Clear? So what is this basically? The relationship is, you don't need to worry about the derivation here. Only two formulas are there. E is equal to 2g into 1 plus mu, and other one is E is equal to 3k into 1 minus 2 mu. So these two are the equations here, equation number 1 and equation number 2. So if you know at least two of the values out of those four, E, G, K, mu, you can easily get other two values, because we have two equations. So if you know, if you unknowns are two, you can easily calculate them. So the relationship between elastic constants are like this. It was observed that once you discover or invent a material, you find out all the values of E, G, K and mu, and they have observed that this particular relationship is maintained between these elastic constants. So any question can come in your diploma examination, where they will ask you to find out some other elastic constant using E and G, maybe mu value using E and K, or K value using E and mu, and so on like that. Clear? So I hope it is completely clear. I hope there is no confusion at all. So coming back to your syllabus, I can see that we are done with this Hooke's law, relationship between elastic constants without derivation. Okay, longitudinal and lateral strains is also done. Points ratio is also done here. Okay, na? Clear? The next topic is basically stress and strain values in the bodies. Next topic is stress and strain values in the bodies of uniform section and of composite section under the influence of normal forces. Okay, na? Clear? So let me explain this guys here. So basically యూనిఫామ్ సెక్షన్ అంటే ఏంటో మనం నేర్చుకుందాం బేసిక్గా. ఓకేనా? యూనిఫామ్ సెక్షన్ మీన్స్, యూనిఫామ్ మీన్స్ బేసికలీ కాన్స్టెంట్ అలాంగ్ ద లెంగ్త్. యూనిఫామ్ మీన్స్ బేసికలీ కాన్స్టెంట్ అలాంగ్ ద length anamata. So let me explain that and then I will stop the video. Then in the next video I will freshly start with that. Okay na? So whenever they say uniform area అని తీసుకుందాం. ఓకేనా? యూనిఫామ్ ఏరియా A అని తీసుకుంటే same area and shape, same magnitude of area and shape, same magnitude of area and shape throughout the length of the member, throughout the length anamata. Okay na? Clear? You can see here, throughout the length there is this uniform cross section. You have like this, you have like this. Okay na? So these are all uniform cross sections. Ante throughout the length, everywhere same shape and same area is there. You can see here, everywhere there is this, everywhere there is this, everywhere there is this. Okay na? So everywhere there is this, everywhere there is this. Understood? Clear? So it is like this. Understood? Okay. For example, if you have a shape like this, oka side emo circular, it side emo rectangle anamata. Okay na? So that is actually made to become like this anamata. So this is not at all a uniform cross section. Obviously over the time shape is getting changed, maybe area also will be getting changed anamata. Clear? So everywhere along the length, throughout the length basically you need to have same value of area, same value of area, and also same value of the shape anamata. So uniform area and ఇది అనమాట బేసిక్ గా. ఓకే, క్లియర్? ఇంకా యూనిఫామిటీ గురించి ఇంకో అదర్ థింగ్ కూడా ఉందన్నమాట బేసిక్ గా. దట్ ఈస్ నథింగ్ బట్ రిగార్డింగ్ మెటీరియల్. క్లియర్? ఇఫ్ యూ టేక్, those are called as composite members. Composite members. Composite members అని అంటే, see here, there are multiple ways అనమాట. You take a member, కానీ that particular member has different materials అనమాట. If you see, cross sectional area till here has some material. Let us take this material to be steel. Okay na? And lopalemo there is some other material which is basically aluminum anamata. This is basically aluminum anamata. That means what actually you are doing is along the radius, okay, you see different materials are there. This is one type of composite section. అండర్స్టూడ్? దీన్ని మనం ఇలా కట్ చేసి చూస్తే ఇలా ఉంటుంది అనమాట. ఇప్పుడు వాటర్ మిలన్ కట్ చేస్తే ఇక్కడ వరకు పొట్టు ఉంటుంది, లోపల రెడ్గా ఉంటుంది. అండర్స్టాండ్? దట్ ఈస్ నాన్ యూనిఫామ్ ఇన్ టర్మ్స్ ఆఫ్ కలర్, ఇట్ ఈస్ నాన్ యూనిఫామ్ ఇన్ టర్మ్స్ ఆఫ్ మెటీరియల్ అనమాట బేసిక్గా. సో కంపోజిట్ మెంబర్ కెన్ బి ఆఫ్ అదర్ టైప్ ఆల్సో. ఇది కాకుండా ఇంకొకటి అనమాట ఏంటంటే లెంగ్త్ వైజ్. ఇప్పుడు ఒక రాడ్ ఉంది, ఒక రాడ్ ఇలా ఇలా ఉందన్నమాట. యూ హ్యావ్ like this, see here. So till some particular value of this length there is steel, till some particular value of this length there is steel, okay na, and this one is basically there is aluminum anamata. So aluminum member is attached with steel anamata basic ga, okay na. So either along the radius there is variation of the material, or either along the length there is variation of the material anamata basic ga. Understood? So I hope it is completely clear. So this is how composite sections will be there. So in the next video we will discuss regarding how to deal with the composite members when you are applying some loads on it. Clear? Some koncham difference vastadu anamata, formulas differ avutayi, because you would see that as the material is different, the metal properties are different. నేను చెప్పాను కదా, every metal will have its unique values of Young's modulus, rigidity modulus, bulk modulus, shear modulus kada. Understood? So that's the thing. So the value of here, if you take the values, so this value is this value, if you take it, so this has ES, GS, mu S, okay na, and there is KS, okay. So steel ki ila raddam, E suffix S, G suffix S, mu suffix S, and K suffix S, okay. And if you take this aluminum ki E suffix aluminum, G suffix aluminum, mu suffix aluminum, and K suffix aluminum ila anamata. So these values are different. So for this again we have E suffix aluminum, G suffix aluminum, mu suffix aluminum, and K suffix aluminum anamata basic ga. This is the one, okay, fine. I hope there is no confusion at all. Clear? So this value will be different. This value will be different because materials are different anamata. Understood? If they are same also, that's only a coincidence anamata. So due to this different values of Young's modulus or these metal properties, the formulas would become little bit different when you deal with these composite members anamata. So I'll show you in the next video in a clear and detailed way. So if you guys want to copy, you can copy this as well. Okay? So come on everyone, please copy this. You can copy this as well. Great, fantastic. So let's meet in the next video.